Okay, so we are continuing with tissues and now looking at another main type of tissue called connective tissue. We've talked about connective tissue a little bit when we were referring and comparing epithelial tissue to connective tissue. Let's review. In epithelial tissue, we have a lot of cells and little to no ECM. And remember, ECM stands for extracellular matrix. Connective tissue, on the other hand, has little amounts of cells and an abundant amount of extracellular matrix. So, big difference when we're comparing and identifying these two major types of tissues. In epithelial tissue, we were looking at these, clusters and compact, regions of cells. Whereas in connective tissue, we'll see the cells, but we're also going to be viewing the components of extracellular matrix. So let's talk about what types of cells we'll see in the connective tissue. There's so many different types of connective tissues that typically the cell type, the more abundant cell type, will change. Okay, so let's start off with fibroblasts. Now, fibroblasts are actually present in all general connective tissues. They're usually the most numerous cell in a connective tissue, and it kind of makes sense because fibroblasts um, secrete fibers and ground substance, which are the components of extracellular matrix. And like we just said, connective tissue has an abundant amount of extracellular matrix. So it kind of makes sense that these fibroblasts are going to be located in all connective tissues and are the most numerous cell type. Adipocytes are also referred to as adipose cells. These are our fat cells. These are going to be cells that store triglycerides or the fats, can be located below the skin, sometimes around the heart and the kidneys. You may be able to view that in lab when we get into the cadavers. With chondrocytes, chondrocytes are the mature cells found in cartilage. And cartilage is a type of connective tissue. These chondrocytes are always located within these little pockets or pools, as I like to call them, pools. Um, their correct term is lacunae, but I think a pool is more fun. I'm visualizing a pool with just a bunch of like little cells floating around. Anyways, osteocytes, these are going to be the mature cells of bone. And yes, bone is considered connective tissue. Then we'll also see macrophages, which, if you remember from Gen Bios, this is a type of phagocytic cell. So it is performing in like immune functions. Um, it is sometimes, I believe, considered a type of immune cell. Um, there are other immune cells and white blood cells found in connective tissue. Some leukocytes, again, leukocytes is the correct term for white blood cell. Um, Sometimes these leukocytes migrate from the blood to connective tissue, and so they can be seen in some tissue preps. So those are the living cells, and again, they won't be in clusters, but we'll still be able to identify them because they will have a nucleus. Then, of course, we have the extracellular matrix. And the extracellular matrix we've already talked about. So remember, it is mostly water. And that water component is what's making up the ground substance. But the other portion of ground substance is like all those proteins and the gags, right? So the sometimes I look at this word and I'm like, how do I pronounce that again? Um, Glycosaminoglycans. Whoops. Okay, I had to really prepare myself for that one. But anyways, we could just call it gags. That's fine. So majority of ground substance is water, but there is also going to be these gags floating around. Cool thing about these, they actually allow the movement of ions, and they help with water storage and water retention. So that's going to keep connective tissue hydrated, and it's going to help connective tissue resist compression. So, okay, we have kind of already talked about how the skin is epithelial tissue because epithelial tissue lines organs. So, underneath all epithelial tissue, if we remember, there is connective tissue because epithelial tissue is avascular. So, connective tissue is the blood supply for epithelial tissue. Okay, the reason I'm bringing this back up is because you have this epithelial tissue and then you have connective tissue underneath it in your skin. All right. So, the reason that we can have and sustain pressure, one of the reasons, you can have things press onto your skin and your cells don't just fall apart and collapse and things bounce back is because of that connective tissue underneath the skin with the ground substance having this water retention so that there's a lot of stability. The cells are bound and you have this resistance to compressive forces. Very cool, very fun to think about. The other aspect of extracellular matrix is, of course, the fibers. The fibers, there are three of them: collagen, elastic, and reticular. So let's start by talking about collagen. Okay, so collagen fibers are the strongest fiber in the body. Okay, and these are protein fibers, by the way. All right, so this allows for tensile strength in tissues. It allows for some tissue flexibility. Um, it can vary between its function, can vary between tissue, but it is very common in a lot of these connective tissues. It also is going to help with the cushioning effect that we were just kind of talking about. Another reason that our skin and our body doesn't just fall apart when pressed upon is again because of the collagen fibers. That's exciting. So we love them. But again, tensile strength to the tissue. Okay. Elastic fibers, these have the protein elastin. All right. And you can probably guess from the name what functionality these types of fibers have. Elasticity. Yeah. So in elastic fibers, I think it's about 150%. Yeah, 150% these fibers can be stretched up to 150% of their relaxed length. So that's crazy. And then they are able to come back to their resting state. So you can imagine that these would be really beneficial in locations like the lungs, right? Locations where there's constantly this maybe internal pressure that is either increasing and decreasing regularly. So the structures surrounding or the tissue surrounding the organs and structures need to be able to keep up with that type of function, right? Reticular fibers, these guys, I think of them as like a mesh or a netting, okay? They are going to be providing support and some strength. They're not as strong as collagen, but they're much stronger than elastic, okay? They kind of branch and have they form like a network or some sort of framework, and they are oftentimes kind of supporting soft organs throughout the body because it's like a net. It's like a mesh framework. I literally just think of like a net holding up the spleen sometimes, and I'm like, thanks, reticular fibers. Anyways, okay, so those are our three protein fibers. that make up the extracellular matrix. When we're identifying parts in the connective tissue, we're not going to be able to identify ground substance. We are, however, going to be able to identify these fibers. So I will need you guys for each connective tissue type to be able to tell me what tissue it is, where it's located in the body, what type of cells are found there, and where the cells are being held, if applicable, and what type of fibers are seen, if any. Okay? So here we go again, characteristics, right? We got to keep in mind that we're not seeing compact cells, we're seeing extracellular matrix. And again, connective tissue is vascular for the most part. Cartilage is not vascular, but we'll get there. And so we will see connective tissue deep to epithelial tissue, which is avascular. And again, we have those 3 protein fibers that we will be identifying when we look at these tissue preps. Now, with connective tissue, we have 2 categories that we will look at first. Okay, so connective tissue is broken into the embryonic connective tissue and the mature connective tissue. For the embryonic connective tissues, there are 2. I don't need you to identify these, but we need to be aware of them and talk about their location. Okay, so first type of embryonic tissue is called mesenchyme. Chyme. That CH makes a K sound, chyme. So mesenchyme. Now, the reason that all connective tissues are grouped together is because all connective tissue develops from mesenchyme. Okay, and mesenchyme is located in the embryo. So this mesenchyme is kind of lost as we mature and grow. However, it can be still seen in adults in some blood vessels and the mesenchyme tissue would be helping with repairs, but that is rare. Okay, so all connective tissues developed from mesenchyme, and that's how they're all categorized as connective tissue. Right, and mesenchyme is located in the embryo. And then we have the mucosous connective tissue. And this is going to be found in your umbilical cord embryonic tissue. So we do not really see this type of tissue anymore because the umbilical cord, of course, has been cut. Okay, so again, we don't need to identify these, but we do just need to understand that these 2 are part of the embryonic connective tissue, and especially comprehend that connective tissue all connective tissue develops from the mesenchyme. Having this abbreviation, CT, that just stands for connective tissue, if you feel like doing that for any of these tissues, like instead of writing out epithelial tissue every single time and you just want to write ET, that's totally appropriate and I would accept that. That may vary for your labs, depending on your lab instructor. So the remaining types of connective tissue fall under the category of mature connective tissue. So remember, there were 2 categories, embryonic and mature. The previous 2 that we just talked about, those were embryonic. We're all done with them. Moving forward, now we're looking at mature connective tissue. Then, within mature connective tissue, it gets broken down into proper and specialized. Okay? Let's talk about proper first. In connective tissue proper, we have 2 subcategories, loose and dense. When we're referring to loose and dense, we're talking about the protein fibers, okay? In connective tissue proper loose, these protein fibers are loose. I don't know how to say that. They are spread apart. They're sporadic. They're not compact. Okay. In connective tissue proper dense, the protein fibers are densely packed. Okay. And once we get some visuals, that'll make a little bit more sense. Now, in loose, we have 3 types of connective tissue. So we would say loose areolar connective tissue, loose adipose connective tissue, loose reticular connective tissue. Okay, I do need you to say the full name. Then we have dense. In dense, there are 3 types of connective tissue. We would say dense regular, dense irregular, and dense elastic. Okay, so with these, we're really paying close attention to how the protein fibers are arranged. Okay, in the specialized connective tissue, we have two groupings. Okay, we have supporting connective tissue and liquid connective tissue. These terms are not listed on this bracket. However, cartilage and bone are considered supporting connective tissue. Blood is considered liquid connective tissue. Okay, and all 3 of these can be considered specialized. With bone, we'll look at spongy versus compact. And with cartilage, there are 3 different types of cartilage. So we would say elastic cartilage, connective tissue, fibrocartilage, connective tissue, and hyaline cartilage, connective tissue. Okay.